Okay,
So,
we start.
yeah, I'm Ilya. It's wonderful to see you all here. It's a geospatial dev room, which means we use, we like, and we work with maps. And we do that in multiple ways. Like yesterday, I believe most of you had to find your restaurant for the evening or your hotel. Who did open their map app and type something into search field? Oh, you see, that's a lot more than I expected. And that's the thing that we do often, just typing things into application. And the application gives you a coordinate location where you go to. That is called geocoding, converting your phrase into a location on the map. And that's one of the three pillars of applied cartography. Finding things, plotting a route, displaying a map. But when you take a geospatial specialist and make him or her work on geocoding, I doubt they will like it. Because underneath all that, geocoding is not exactly a mapping problem. It's more of a language processing problem. You take a phrase, you split it by tokens, you do a full text search, return a result. It's not about maps at all. But the reverse problem, given a location, producing a understandable string or address is much more interesting and challenging, as I found out. I was tasked with installing a reverse geocoder at my last job in Juno, that's a ride-sharing operator in New York. And instead of using one of the pre-built solutions like Nominatim, I decided to try to write my own geocoder. Because how hard can it be? Like, how do you know you're in Belgium right now? Given your location, you can just take a set of country polygons and do a simple point and polygon search. And you will get a result like Belgium, which you can produce to a user. Point and polygon is one of the basic operations in geospatial. It's highly optimized. There are very fast algorithms. You can do that 1,000 times a second. And you can find your country. Except in the real world, sometimes you can get 2 or 3 countries at once. Like on the river, I think between Luxembourg and Germany that belongs to both countries, or disputed territories like Crimea or anything. Sometimes you can get no countries at all, not only in oceans, but also there are unclaimed territories like in Africa and stuff. You have to convey it somehow to a user who requested the coordinates. The same for regions, but how do you get a city? Like, how do you know you're in Brussels, for example? Again, you can take a set of city boundary polygons and find out, yeah, you're in Brussels. But what if you're in a smaller town or a village and there are no databases of village polygons? All you get are points. Like, how many people can fit in a single point? Thousands of them, because many towns and even cities often reside in any databases like points. So what you need is finding a nearest point. And that is, again, a basic operation in geospatial. It's indexed, it's optimized, you can do that a lot. But cities are different. They are of different sizes. Sometimes there are both point and polygon for a city, like in OpenStreetMap. There are points for city regions, neighborhoods. And to know where you are, you have to make a lot of queries. Point and polygon for countries, for regions, nearest point for cities, rank them, choose what you need. That sort of queries, and these can take a long time. You have to optimize it. And one of the useful things are Voronoi polygons. Basically, for each point, they build a polygon from inside which that point is the nearest one. With that, basically, you convert your nearest point request to point and polygon request. And doing a bit more bounding, a bit more optimization, preprocessing, and you can get the entire administrative hierarchy from country to city neighborhood in just one query, very fast one. That's how I do administrative queries. But frankly, the question which city I'm in doesn't come up often. No more often than what year it is. It can come handy, but not for most people. I know I'm Brussels. What I'm interested in is more precise location, which means address, which means house number and a street. For most countries, it's house number and street. How do you know that? There are multiple open databases with address locations, which means coordinate and address. You can use them very simply. You can find nearest point again and get your address. Like, what is address for the red point? You can shout. No, it's case 7. Okay,
Which point is red?
this one. I'm really sorry. Okay.
Case 7.
Yes, given this database, it's case 7. It's a pretty close answer, except that in many countries, addresses are given not to entrances, like in Brussels, not to points, but to buildings. That's the case for the United States, for Russia, for Belarus, for quite a lot of countries, actually. And since buildings are not points, these results can sometimes be not very specific, not very precise. But thankfully, we use OpenStreetMap. OpenStreetMap has a lot of building polygons with addresses on them. So the task of finding an address for a point for reverse geocoding, in most cases, is very simple. You just find a nearest addressed object in the database and you're set. And that is how virtually every reverse geocoder in the world works, including nominating. They keep a database of addressed objects, and they find the closest one and return its address. Very fast, very simple, works in most cases except some corner cases. Which corner cases? Like corner buildings. They often have addresses, they're addressed by 2 streets or more streets they're on. How do you map that? Like, because it's one object, it can have 2 similar different properties. Well, in OpenStreetMap, anything goes. So people just add 2 address points inside and are done with it. So what is the address we expect to know about this formerly red point? So somebody answered K5. Why?
Because it's located on K Street.
Yes, exactly. You're on K Street. If you give P6 address, then your car or your friends will wait at the wrong side of the building. So you need K5. But here, if you employ nearest object lookup, you will get the wrong address. Why is that? Yeah. So it turns out that some points need special processing. Like when an address point is inside the building, it's not actually a point, it's a property of the building. So it doesn't matter how far it is. You just take distance of closest building and take address from a point. And you can imagine your imaginary query for looking up an address becomes much more complex because it's not a nearest object anymore. It's not about point and polygon. It's a special processing in which you find closest building, then find points inside it, and find a proper address point, and so on. And in OpenStreetMap, it can be even worse. Like a building can have many addresses on different streets, like up to 4 streets. And you might need to find a proper location, proper address description for any point, including points inside the buildings. What is the address for this point? I don't know. It can be anything. But you have to produce a string that will be understandable, that people will know how did you come with this string. And in OpenStreetMap, anything goes. So these were simple cases. There are more interesting cases, like, for example, a location inside the building that has an address itself, that has addressed point with different address inside, and there is also a cafe with different address. So these can be there for different reasons. So is it here number 14 or still 16, because this point is not too far? And cafe most definitely is about just a single entrance, and move away a bit and it's different address. So in these cases, you have to come up with ranking different objects, how they influence the outcome, correctly find distances on which addresses work, and so on. And again, in OpenStreetMap, you can find anything like addressed building inside an addressed building with different addresses. This might be correct because one is underground. We had to fight for this case. And there are addresses can go in anything, including territories. So like imagine a school with a very big yard, it's fenced, and the entire school has got an address. And when you're standing at the point, which address would you like to give to your friend to meet? Is it K5, like who knows where it is, or K6, which is across the road? It's farther from you, but seems like more correct. And you have to account for that in your hypothetical query for looking up an address. Like in this case, we might pre-process the data to move address from a territory to the biggest building in sight. OpenStreetMap data model provides multiple challenges, some of which are quite hard, even for me, like address interpolation. What is the address of that point? Anybody? Take a guess. Yeah, for example, K6. It's plausible. You just find nearest point on the interpolation line. Interpolation means there are multiple sequential numbers on that line from 2 to 16. So maybe K6. But in the real world, there might be no such building. There might be K2, K10, and K16, and that's all. So using just interpolation data, you will give a user a non-existing address. Is it okay to give them that? It's roughly precise, but if they type that address into a different app, they will find nothing, and it just won't work. So there are multiple things you have to consider while doing reverse geocoding, and it's all quite fun to do, especially when testing. And the point of this talk is all I've been talking about is real. It happens in OpenStreetMap database, and the geocoder that I've been writing accommodates for these cases. Like all these came through testing on the real OpenStreetMap data. The geocoder was published. It was installed in production. It could perform like 50 queries per second. It performs better than Nominatim and other geocoders because it's not just nearly addressed object. It knows about all these corner cases. And it is open source. It was written for Juno company, and Juno company has ceased to be. It's no more ex-company. But I don't want it to be buried among GitHub open source projects. So I urge you to open this link and just take a look, because it's several dozens of screens of SQL code, heavily commented, with hundreds of unit and integration tests. It's really simple to deploy. It has Docker container. It has, it works on a pretty plain OSM2P GSQL database, and it's very fast. I don't work on that anymore because I'm now in a different company, but I'll be happy to find some more corner cases to think about how to accommodate for them and maybe to improve this and see this geocoder used. So, thank you.
Are there any questions? Yes, the first one.
What's the reason you don't use this at your current company?
Because my current company doesn't use OpenStreetMap for geocoding. It's much bigger. I work in Lyft now, and it has their own data with different constraints.
Second question, yes.
Is addressing as it is now a close enough leaky abstractions? In other words, what practical problem are you solving for taxi companies nationally by solving this problem? If the taxi shows up close enough, I just see it.
Well, I'm solving a problem of making an address easy to understand, easy to pronounce, because many taxi drivers do not use taxi app for navigation. They switch to Waze or Google Maps, they type in the address, and they go to the point. So the address has to be correct so that they plot a correct route. And basically that's it, that you need a location that's easy to understand enough. And services like What3Words or PlusCode, they don't solve this because few people can process these codes.
Okay, next question.
Can you go back one slide for the link?
Of course, it's the same link if you use QR codes. But yeah. You had a question? Let's. I think she asked. Okay, go ahead.
I wonder what's the geographical coverage of these two, and maybe only three maps in general. How good would it be, for example, to work in countries where there's not precise address, like African countries, that just some buildings, or even Arab world? What work in general being done, maybe in Africa to locate buildings, but geocode, reverse geocoding do work best for a point on map in Africa to get the address.
Right. So will it work in Africa or other countries with low building and address coverage? It will work no worse than any other reverse geocoder, obviously, but in countries with no established street name, house number, address, it may show some weird results. But again, it depends on addressing model in OpenStreetMap. Like in Japan, it probably won't work because the addresses there is very different. It was written specifically for American addresses, but many countries, including Eastern European countries, share the schema, so it will work. But I would be pretty happy to see some test cases and corner cases from other countries.
Okay, we have time for one last question.
So I've used Nomatin in the past to reverse geocoding photos, like several million photos to sort out where they're from. But edge cases didn't work well. Would this tool be better at it?
I guess so.
On a location level, city or
As long as you don't need point of interest information, like your cave is having an address instead of, I don't know, Empire State Building or some name.
Village lab or something.
Yeah, so as long as you need country, city, street, and house number, this should be better. And it's faster because it's just SQL queries for PostgreSQL, and it has lower footprint. I think it's twice, database is 2 times smaller than nominating database. So it should work.
Okay, that's the final question, a short one.
What does the name stand for and how do you pronounce it?
It's GRG. I don't know. I've only pronounced it in Russian, but it's an acronym of June Reverse Geocoder. We were fighting like 3 days on a name and decided to go with the simplest one.
Okay, that was it. Thank you very much.
Again.